Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to electricity and magnetism. And so far we have discussed about electric field, the basic concepts related to it, about the electric field due to dipole, a group of point charges, uniformly charged circular ring, and various other introductory concepts related to that. So in this video we are going to discuss about electric potential and the concept of potential difference. Okay, so everything related to electricity, it has one common thing which is associated with it, which is the source of that, which is charge. Okay, first we discussed about the fundamental concept related to charge. From charge we went to Coulomb's law. From Coulomb's law we went to electric field, and then from electric field we carry out our discussion forward. So before discussing electric potential and potential difference, first we have to discuss about one important thing, which is the potential energy of a charged particle in an electric field, or we can write it as electrostatic potential energy. This. Okay, so the potential energy of a charged particle in an electric field, we can correlate with the potential energy of a mass, okay, in the gravitational field. Suppose we have a mass m, okay, and it is located at a distance or a height of h from the ground. Okay, so here the potential energy of this mass is given by the formula mgh. Mass, acceleration due to gravity, which is 9.8 meter per second square, and then we have the height, that. Similarly, this is the gravitational potential energy, or simply it is also called as gravitational energy. In the electrostatic field, the same discussion, if we convert it or we take it to the electric field, in that case the mass can be replaced with charge, the gravitational field can be replaced with the electrostatic field, this. Okay, and the potential energy which is there, it is called as the electrostatic potential energy. Okay, so a charge in an electric field has electrostatic potential energy. In the same way, a mass has gravitational potential energy in a gravitational field. Okay, so in order to understand this concept, first let us say the same thing. We have a point charge, let us say plus q, positive charge, located at O, and then we have a test charge q0 located very far away from it, theoretically at infinity. So at infinity, the test charge which is located, it has, or it is assumed to have, 0 electrostatic potential energy. Okay, at infinity this test charge has 0 electrostatic potential energy. It is 0 at infinity. This. Now As this test charge is moved from this far away distance from infinity towards this plus q charge at a uniform velocity, there will be some work which has to be done. Now both these charges, the original charge, the source charge and the test charge, they are positive. So it will exert a Coulombic force of repulsion on this test charge. So it has to be moved against the electric force of repulsion to move it closer to O. So that work which is done to move this test charge closer to point O, closer to the source charge, that is stored in this charge as electrostatic potential energy. So electrostatic potential energy is the work done against the electric force of repulsion to move the test charge closer to the source charge. Okay, that. So here let us say that we have this test charge at infinity, and let's say it is moved to this position A. Okay, this position A. So the potential energy of this test charge at A, let's say we call it UA. It is the work done in moving the test charge from infinity to A. Similarly, the potential energy of this test charge plus Q0 at B is the work done in moving the charge from infinity to B. Now as B is more closer to the source charge or more closer to the point O, so more work will be done to move the charge to the point B than to move it to point A. So obviously UB will be greater than UA. Potential energy at B will be more than potential energy at A, because more work will be done to move this test charge to B, which is closer to O, than the work which has to be done to move it to A. So the work done in moving the charge from infinity to B is greater than the work done in moving the test charge from infinity to A. Okay, so this is the concept of electrostatic potential energy. This. Now comes the turn of electric potential. So for electric potential, what we have to do is that, like the electric field, in electric field, in order to define electric field, we had the force which was exerted on the test charge Q0, it was divided by the test charge itself, the Coulombic force divided by the test charge. Here, in order to find out the electric potential, what we have to do is that we have to divide the work done or work which was done to move that test charge closer to the source charge divided by the test charge itself. There it was in electric field, it is force by test charge. Here it is work done on the test charge in moving the test charge divided by the magnitude of the test charge. Okay, this. So here in this case, the electric potential at the point A, okay, the electric potential at point A is simply the work done, electric potential at point A, let's call it V subscript A, the work done in moving the charge from infinity to point A divided by the test charge value, or which is simply the electrostatic potential energy of the test charge at point A divided by Q0, and similarly the electric potential of the test charge at this point B, electric potential at B is given by VB the work done in moving the test charge q0 from infinity to B divided by the test charge value, which is the electrostatic potential energy of the test charge q0 at point B divided by q0. So here, in order to define be it electric field or be it electric potential, there are two things which are always important. First, the source of the electric field or whatever which is producing the source, that is the source charge, and the test charge. So it is always relative to these two things that everything associated with electricity it is defined, be it anything, Coulomb's law, the Coulombic force, electric field, electric potential, everything. So electric potential is simply the work which has to be done on the test charge to move it closer to the source charge against the force of Coulombic force of repulsion divided by the value of the test charge itself. So if we consider a unit positive test charge, that is the value of q0 is 1 coulomb, then we will have VA as WF phi A or UA and VB is equal to W phi B or UB, this. Okay, so the electric potential at any point in an electric field, okay, at any point in an electric field is simply the amount of work which has to be done in moving a unit positive test charge from infinity or a far away distance to that point, to that particular point against the electrostatic force of repulsion. Okay, see, here both are positive, so there is a force of repulsion. If it would have been opposite charge, then it would have been attractive force. Okay, so electric potential is simply work done by charge. Okay, so here we can also write as the potential energy U, okay, potential energy, we are the electric potential which is defined at any point is simply the work done by charge or the electrostatic potential energy divided by the charge U by Q. So we can write the electrostatic potential energy as QV, product of the charge and the electric potential. Okay, now the SI unit of electric potential, it is defined in terms of volts. The unit of electric potential for electric potential, the unit which is defined is volt. Okay, volt. So this means that the unit or the SI unit of electric potential 1 volt means 1 joule of work is done to move a charge of 1 coulomb against the electrostatic force. Okay, 1 joule of work is done in bringing a unit positive charge, that is 1 coulomb plus 1 coulomb of charge, from infinity to that particular point against the electrostatic force. That means 1 volt. So 1 volt simply means 1 joule of work is done for that. Okay, 1 joule of work is done to move 1 coulomb of charge from infinity to any particular point on the electrical field. Okay, 1 joule by 1 coulomb, that is 1 volt. Okay, now electrostatic potential difference, electric potential difference. between any 2 points. So electric potential is defined at any particular point with respect to infinity, okay, from infinity to that point, that is electric potential, absolute. It is defined in terms of absolute because the reference potential energy at infinity, it is defined as 0. That's why when we say electric potential, simply electric potential, it means it is defined with respect to infinity. But when we say electric potential difference or electrostatic potential difference, it is with respect to 2 points at different values of electric potential. So here, let's say, for example, we say that the electric potential difference between point A and B is 12 volt. Okay, it is 12 volt. It means that first we have to define this point. So it means, let's say we have this point at infinity, we have a test charge here. So it means this test charge, which was originally located at Q0, the work which had to be done to bring it from this infinite point to this point A, let's say that is W phi A, and then this test charge again, if when it has to be moved from this point to this point, it is W phi B. Okay, it is, we can also write it as UA, this we can write as UB. Now VB is simply W phi B by Q0 and VA is W phi A by Q0. Now UB is greater than UA. So obviously VB will be greater than VA. So here potential difference between these 2 points B and A is simply VB minus VA, which is W phi B by Q0 minus W phi A by Q0, which is W phi B minus W phi A by Q0. Or we can say it as the work done in moving the test charge from A to B against the electrostatic force. So the potential difference between these 2 points or any 2 points, let's say the potential difference between point A, B and A, VB minus VA, okay, so the potential difference between these 2 points A and B, B being at higher potential at A, this is the work done in moving the charge, work done in moving the charge, the test charge from A to B, that is lower potential to higher potential, lower potential point to higher potential point. See, VB is at higher potential than A. So the potential difference between these 2 points is the work done in moving the test charge from a lower potential point to higher potential point against the electrostatic force of repulsion divided by the test charge. So we can also write it as low to high potential point against electrostatic force divided by the test charge value. Okay, this the test charge value. This. So always understand, whenever we define potential difference, it simply means we have 2 points which are at different electric potential values. One is at a higher potential, the other one is at a lower potential, the 2 points, and it simply means the work done against the electrostatic force in moving the test charge from the lower potential point to the higher potential point. Everything which is defined with respect to infinity. So for that, first we have to understand electric potential concept, then we can go to electric potential difference. Okay, this. Okay, so the SI unit of potential difference is also volt. Okay, electric potential, the same thing, 1 volt. So we can define SI unit of potential difference is also volt. So we can say that the potential difference between 2 points is said to be 1 volt if 1 joule of work, okay, if 1 joule of work is done in moving a charge of 1 coulomb, from a lower potential point to a higher potential point against the electrostatic force in the electric field. Okay, so 1 joule of work in moving a charge of 1 coulomb from a lower potential point to higher potential point. Always remember this definition. Okay, the potential difference between these any 2 points is the work done in moving the test charge from a lower potential point to a higher potential point divided by the test charge itself. That is the definition of electric potential difference. Okay, so here when we say the potential difference between these 2 points is 12 volt, it means that if the test charge value is 1 coulomb, then 12 joule of work has to be done. Okay, 12 joule of work has to be done in moving a charge of 1 coulomb. Okay, charge of 1 coulomb from A to B. A the lower potential point, B the higher potential point. Okay, so if the test charge value is 1 coulomb, it means 12 joule of work has to be done in moving the charge from this lower potential point A to higher potential point B against the electric field. So this is the concept of electric potential difference. So first we discussed about electrostatic potential energy, then we discussed about electric potential, and then we discussed about electric potential difference. Okay, so I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.